Hey there, LED lovers. So I'm here with a video to explain our new product, the PiPixel, and go through the construction of it and usage. As you're hopefully aware, we have our previous product, the All Pixel. This is the original, and the All Pixel Mini, new and improved version. These, of course, help you hook up nearly any type of LED strip to pretty much anything with a USB port that can run Python or control anything over serial. But sometimes we really just want to hook things up directly to a Raspberry Pi. I've got Raspberry Pis embedded in just about every little display and project around, and sometimes it is just easier to bypass that. It's supported in BiblioPixel. You can go right over the SPI port or over the GPIO ports. And the problem we run into is it's a pain to hook up the GPIO and get power into that and all that stuff. I want to just plug it in and go. So that's what this is for. The PiPixel provides power in and a nice little voltage buffer to bring you up to the 5 volts that most LEDs run at, as well as then the data and power output. It's very simple. It's a simple, cheap kit. We're going to be selling them for $850. And I'll show you the details. So here's all the parts. First and foremost, of course, we've got the PiPixel PCB. Everything's nicely labeled and laid out there. And this, of course, as you notice, is smaller than a normal Raspberry Pi hat. This is designed to fit on the Raspberry Pi Zero as well, so it's a nice companion to that. Fits right on there. Same exact size, but of course, it will also fit right on your standard normal size Raspberry Pi, even including the Pi A. This is a Pi 3, but basically any Pi that's ever existed, well, with the exception of the original Pi, which has a smaller header. This will fit on all of those. So that's the PCB. Of course, you've got the header to hook up to the Pi. We ship it with a standard height female header, which is great for using with the Pi Zero. We know that there's other options. There's extended height. You can use a male header then with a ribbon cable. You can use the pass-through if you want to stack another Pi hat on top of this. Those kind of get expensive real fast. We were trying to keep the price down and know that most people would probably just use this female header. So that's what we've done. We will provide links, of course, to great places to get all of the other headers should you want to. Then we've got both the power input options. This is your standard sort of 2.1 millimeter barrel jack, and this is just a 2-pin screw terminal. You can use either or of these, and I've got actually a little trick I'll show you later for powering the Pi via all of this with a sort of cut USB cable. So there's that. Then we've got sort of the core of keeping all the voltages happy. This is just a level shifter. Technically it's actually a buffer chip which raises the 3.3 volts on the Pi up to 5 volts. Some strips work with just 3 volts, but 5 volts really keeps them happy. That's where they're at. Then of course we've got the data and power output, just a standard 4-pin header. This is the exact same one that's on the All Pixel and All Pixel Mini. And then a little tiny jumper and little tiny jumper shunt that I will go into later. That's kind of more in the details. So we're going to assemble this right now. It's relatively easy. You don't need a whole lot of soldering skills. I will say a vise helps should you have one handy, but this should be doable without that, of course. So I'm going to start on here with the header, just because it's kind of one of the bigger things to deal with. And actually, now that I've said that, the vise can kind of go away for a minute. So you want to just take the header. Obviously, in this case, because we're using this standard female header, which is going to go onto the male header on your Pi, like this, we want to put this on the bottom of the PCB, so it just slots in there like that. So the reason I'm not using the vise right now, and I'll hopefully zoom in so we can see this a little bit better, is it's just kind of easier to get everything situated when it's just sitting there. Otherwise, it's hard to keep this header held in. So what we want to do is just tack on one single pin. That's all we're going to do right now. Then I'm going to put it in the vise. This is just enough to kind of keep it on there. You'll notice it's not straight. That's okay. We'll get there. So now we can put it in the vise. And as I noted, that is not straight, but that's okay. What I'm going to do is heat that pin back up again. I'm pushing with my finger behind it. Obviously there's no real metal sticking out of that side, so you're not going to really worry about melting yourself. But now, as you can see, it's nice and perfectly straight on there, both sides. So now we can solder all those on and not worry about it falling out. So I'm going to widen this up a little bit so I can actually get to all of those pins. Nope. One of these days I'm going to build a motorized solder vise. It's my $1 million idea. No one steal it. Alright. Someone's probably already done it. I just need to go find the files. Alright, so now we've got the rest of those pins. Note to future editing self, awesome montage music. We're gonna montage straight through this. Alright, that's it. That is the header. That's really the hard part, to be honest. Not hard, just tedious. So now we've got that on there. So next up, I'm going to do the barrel jack. If there was anything that was maybe harder than the header, it's this. And this is only because, as I close this again, where's that motorized vise? This is only because basically there's relatively large holes and you got to fill in some pretty big gaps. So this just snaps right in there. Now it may be a little bit loose. It kind of just depends upon kind of how your header came from the factory, depending upon how the pins are bent. But what I found is with something like this, because I need to flip it over, you can either, if you want to leave it in the vise, you can kind of use a little bit of tape to tape over it, just to hold it on there temporarily. Obviously this is going to come off. So bring this up. So now, just to keep it on there again, we're just gonna tack on one of the pins with just a tiny amount of solder. All right, now the tape can come off. It's not gonna go anywhere. So, as you see, this is on there pretty good. Although it's a little bit proud, a little bit sticking out there at an angle. So, again, just like with the header, I'm going to put my finger behind it now that I can hold it, heat up that solder again, and just push that back into place. You kind of hear it click, and now everything should be perfectly straight. So there we go. So now that's much better. So now we obviously don't want to heat that one up again just yet. We will solder the other ones. And just a note about the specs right now. So this is just like with the all-pixel. We rate this at about 5 amps, which is pretty much the most you're going to want to do with a single strip of LEDs before injecting more power along the strip. We found that it's good enough for most people. It's also the only real way that we can source these barrel jacks without being exorbitantly expensive. So now I've got the last one. Those other two are on there. And note, you do want to try to fill these up as much as you can. Just be patient, kind of keep feeding solder in there. There you go. So those are all set. So that's that power input. Okay, so now we're going to do this other power input, the screw terminal. So this is just to give you another option. If you don't want to use the barrel jack, you can just use 2 bare wires and screw them in there directly. So that's going to go in there. Again, these things don't really stick in there real well. There's a little bit of play. So I'm going to set this down yet again, just kind of tack one of these on. Alright, so that one is on enough. Same process as before. Kind of put my finger behind it, heat up the solder, get it back on there. Alright, so that's that. So now we've got the other power input on there. Before I get too far and get this too populated up with stuff, so I'm going to put on the jumper. So you can see on this jumper pad in the middle, it says data pin select. The options are SPI data, GP18, which stands for GPIO 18, and GP13. Most of the time, you're going to want it on SPI data, because generally when you're using a Raspberry Pi, the type of strips you use are SPI. So that's APA 102, SK9822, LPD 8806, WS 2801. If none of those numbers make any sense to you, please check out the links on this video. We've got all the details for all the different type of LED strips, everything that this is going to support out of the box. And then the GP18 and GP13 are, you can use them pretty much for anything you want. Those are literally hooked up to GPIO pins 18 and 13. And predominantly what those are there for is we actually support, it's a little bit more complicated to install, but not honestly that bad. Directly on the Raspberry Pi through PiPixel, we support driving the WS2812, or as they're more colloquially known, the NeoPixel LEDs. So you can use either of those pins. It just depends upon how you set it up in software, but that allows you, we've noted like some hats use one of those pins or whatever, and we don't want to get in the way of those. So you can select which one you want. So I'm just going to put this jumper on here, and that's what that other jumper shunt is for, and that's just basically a selector. So this is going to go in this footprint, and again, you know, kind of a little bit wobbly on that, so we're going to just use the table to hold it in there as we have with the others. Yet again, just going to tack one of these in here. So there we go. So that's on there. So as I mentioned, there is the little tiny jumper shunt. So on this, I'm just going to stick this right on the SPI data one, because that's pretty much the standard one you're going to use. Second to last, we will install the all-important buffer chip. It's just a quad channel buffer, so 3 volts data signals come into it, and 5 volt data signals go out to make the LED strips happy. This comes in a nice little protective foam. We're going to pop that out, and as you note, the pins are kind of bent out to the edge. So just press those kind of up against the table to bend them in a little bit so that they'll fit in the socket. So you can see now those are bent in a little bit nicer. Now note, this has a notch at the top of the chip, and the PCB shows a notch. Do not get those wrong. These need to be lined up. This is probably one of the most important things. So this, fortunately, since the pins are bent, should slot right in there. So again, notches at the top. We're good to go with that. So I'm going to flip this over. It's in there enough that it's not going to fall out, but I will note that it is probably lower than it should be. So yet again, going to tack a pin and then put a little bit of pressure on the back, the finger, put that on there, and then we're good to go. So now just finish those up. Alright, so there we go. That is the buffer or level shifter chip as we're using it here. Last thing is, of course, the power and data output. So, yet again, gonna have to kind of rest this up against the table to make sure it stays. So that's good and straight. Alright, and there you go. We've got a finished PiPixel. That's all you need. So we got power input option B. Of course, we got the data pin selector, your level shifter, and data out. Next up, show how you use this. Like I mentioned previously, you can get a different header than what we provide with it. This is just sort of the standard, what we figure most people will use. We didn't want to overinflate the price by throwing a bunch of headers you probably didn't need into the package. So this is easy, but if you want to run this on a separate cable, there is, you can use a male header on here, or one of the extended pass-throughs, so you get the female and male. Or you can use one of the extended height males. Now, you'll note that this on here, fits perfectly nicely. I won't actually plug it in just yet on the Pi Zero. On a full-size Pi, it fits just the same. The one difference, and this is the only reason why you might ever want an extended, is you'll note the power output here, power and data output, is kind of hiding a little bit behind the USB ports. We've actually found, with normal, sort of smaller gauge cables that come with these strips, that's not really an issue. It just pops out over there. So, however you want to run that, however you want to set it up for your particular use case. So anyways, yeah, we'll just snap this right on to here. That just goes straight on. And now you've got this nice little stack. PiPixel on top and the Pi Zero on the bottom. And actually, no, this is a Pi Zero W. I'm using this just so I can get some network connectivity to it. You won't see me actually hook this up to any monitor or keyboard, and that's because this has already been configured with the SD card that's in here to connect to my network, and I'm using SSH to control it remotely. Of course, because you can do that with PiPixel, just run a couple of Python scripts, even get a nice little remote user interface in the web browser for it. So now that that's in here, now you're going to say, okay, so now I got to power it off of one of these, and you got to power the thing separately. Well, I'm going to kind of go through a little bit of a trick you can do with this. Now, just please note, this is a kind of do at your own risk. It generally should be fine because most LED strips are 5 volts. But there are some LED strips that are 12 volts. So the barrel jack and the screw terminal are directly connected. There's nothing in between them. There's no buffering. There's no voltage regulation. Whatever goes in here is available on here. So what I'm going to do is I'm going to take this cut off poor micro USB port, which I've thanked for its sacrifice, and I'm going to connect it into the screw terminal and then plug it directly into my Pi. It's a little bit grotesque, but it's convenient. Because I've already got a beefy 5-volt power supply that can provide up to 8 amps, so that's going to allow me to provide, which is obviously, again, more than this is rated for, but it's just the power supply I have on hand that's going to provide the power to the LED strips themselves. And then that way, there's plenty of extra power to run the Pi off of, even a full-fat Pi 3 with its, higher power requirements. But just remember, if you're using any LEDs other than 5 volts, do not do this, okay? Just connect this to your normal 5-volt Raspberry Pi power supply like you would any other. So first things first, obviously, is I gotta, loosen up the screw terminals for this power, because what's going to happen is I'm going to plug this 5-volt plug over here. Just trust me, this is connected to a power supply over on the other side of my desk. I'm going to plug that in here, and that's going to provide it over this wire to the rest of it. So obviously make sure polarity is good, so we've got ground and 5 volts, so those go in accordingly, black and red. And yeah, I guess I should note that for people that don't know. In electronics, black is ground and red is voltage. Usually 5 volts in this case. So I'm gonna screw those in there. Now this is missing two cables coming out of the wire. There's always usually a white and a green. If you cut one of these open and the colors are not black, red, white, and green, go no further. Here be dragons, because I can't guarantee to you what voltages those are going to be, what's the data, what's not. So move on. So now that I've got this connected like this, we can just plug it directly into the power one. If I can remember. Okay, yeah, so the power one is the outermost. So we're going to plug that in there. So now we've got this little bit of a loop, but again, this is just sort of convenience. Otherwise, I would have had to plug this into something else. So now I need LEDs to hook up to it. So for test purposes, I'm going to use this. This is the Wyolume and Maniacal Labs Ultimate by 8. It is a tiny 8 by 8 matrix of the APA 102, or sometimes you might know them as dot star. That's what Adafruit calls them. But that's all they are, just standard APA 102 LEDs. And I'm going to connect this directly to here. So in this particular case, of the way that I've got this wired up, I've got 5 volt data clock ground. This is just the wires that I had. So again, loosen up the header, and then that can just go straight in there. No, I mean, if you wanted to, when you were hooking this up and you didn't want the screw terminals, I mean, we provide these because they're convenient. You can connect and disconnect your LEDs. If you wanted to solder a 4-pin or even 3-pin connector directly to this, that's fine. And also, note, this obviously has 5 volt data clock and ground. From top to bottom. Some LEDs, like the WS2812 or NeoPixels, are only 3 wires, so they only have a data, and that's fine. Just hook up to data, just ignore the clock. That's perfectly okay. And again, I've still got this hooked up to SPI because the APA 102s like this are a SPI interface. So now that is as connected as it's going to be. And all we got left is to provide power. Alright, so we've got this all hooked up. Now again, like I mentioned earlier, I'm connecting to this remotely over SSH because this is set up wirelessly. And I'm going to just run an animation on here. There you go. So we've got it running Bloom. This is of course running BiblioPixel. We're using the new BiblioPixel projects feature, which is really nice. Just a simple JSON file to get this all going. There will be links to samples for those, so you can literally just solder this together, plug it in, run. You don't even just have to install BiblioPixel, call a simple command, run, and you'll be able to get something very similar to this, depending upon the display that you have, of course. Now, like I noted before, this supports the APA 102, SK9822, which is a kind of similar clone, the LPD8806, WS2801, the WS2812 or NeoPixels, and really any LED strip type that can use SPI. Honestly, you could use this for any device that just required an SPI connection. It's not really specific to the LEDs themselves. It's just a buffer for the SPI output as well as a GPIO 18 and 13, and that's it. There'll be plenty of documentation on the wiki that we will link everything to, and hope you enjoyed, and let us know if you have any questions. Check out the Maniacal Labs Google users group, which will be linked in. You can email us for support anytime there. Get help putting this all together, and there will of course also be a full build documentation of how to go through this step by step.